Hi, my name's Hayden. Welcome back to solving Leetcode problems until I get a job. This is, I think, day 8, and I'm going to be solving Leetcode 2873, maximum value of an ordered triplet 1. So the problem goes as so. We have a zero index integer array nums, and we want to return the maximum value over all triplets of indices I, j, and k, such that I comes before j and j comes before k. And we want to find the maximum value where the value of a triplet is equal to nums I minus nums j all times nums k. So for example, if we had I, j, k here, the value of the triplet would be 6 minus 2 times 7, which I believe is 28. All right, so this is the problem. We want to maximize this value. How do we want to approach this? When I see a problem like this, especially when it has multiple indices, my first instinct is, how can I make this problem easier to solve? And generally when I do that, I'm like, how about I try and solve a few problems with one of these indices set? So let's look at these indices. Which one would be the best to have kind of constant when we look at the problem? And I'm like, it would probably be j. Usually the middle element is a safe bet, especially when you have 3 elements. But the reason that it's so is because if I have j set, it's easy to find the maximum value of a triplet. It's just going to be, because j set, it's going to be the maximum possible I, or num of I, and the maximum possible value of k. Because this is a multiplication. Because this is multiplication, we want the biggest possible k, because it'll just make it bigger. And then we want the maximum possible, nums I, because making a bigger nums in subtraction will also make this side of the equation bigger. So j is actually a really good fit here. Obviously, though, we can't just go along and assign j to every element and like go through j here, j here, j here, j here, j here, because if we were to just do this naive search method, it could potentially take O of n time, because you would have to iterate over, oh, is the maximum I here, maybe here, here, is the maximum k element here, here, here. So we're going to have to do this a little bit more intelligently. How will we do that? Well, we're going to do that by storing the maximum elements left and right of an index. So we're going to do this with an array. We're going to call this our max right of index array. And all this is going to be is a simple array that's going to store the maximum value right of this index in nums. So this is kind of a throwaway value here because there's nothing right of 4. But then we're going to look, okay, if we're at index, what is this, 6? If we're at index 5, what's the maximum element right of it? We would be saying, let's look at all the elements 4, dot, 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 or we could just be like, hey, because this is the maximum element of right, the entry to the right of this in the array is also the max of all of these potential elements. So this really just comes down to, all right, what's the max between 4 and 0? 4. All right, let's continue. What's the max between 5 and 4? 5. And this works if we keep going. What's the max between 7 and 5? And because this element represents everything to the right of this element, this represents the max over here, we can just keep taking, we can just keep taking this element or this element. So if we just continue through with max of 2 and 7, 7, 8 and 7, 8, 6 and 8, 8. All right, and then we're also going to have a left array. All right. And we're just going to do the same thing, but on the opposite side. All right, what's the maximum of 0 and 12? 12, obviously. And then 12 actually just goes through the rest of this, as it's the maximum element in the array. All right, we have all this information now. How are we going to solve? So, like I said, we're going to go through and set, quote unquote, we're going to set J. So, if J is right here, and we're going to start at index 1 and end at index 5, because if we have J here, there can't exist an I, because I has to be less than J. And likewise, we can't go with a J right here, because then K would be out of range. So, if we're to start here, the way we calculate a triplet value is going to be triplet. Remember, it's just going to be nums I minus nums j times nums k. So we set j at 6. So we know that this is going to be 6. And then we already actually pre-calculated the maximums to the left and to the right of j. So we can actually find the optimal k here. So we go, and what's that index 1 in our right array? 8. So the maximum nums k in the situation is 8. All right, and then we can look in our left array. The maximum I element is actually 12. So we've pre-computed these values, which makes this problem much easier. So we're able to solve this, and what would this be? 48. Cool. We're going to want to keep another variable called answer, and it's just going to store the maximum value for all the j's, the maximum opt value for all the j's. So as we iterate through, we'll update ands with new maximums. So right now, ands equals 48. And then we're just going to iterate through the array. All right, let's head to index 2. What am I going to do for this one? All right, nums I, or let's just look at our nums j. All right, so nums j equals 8. What's our nums I? This is going to be our our left, 12. And then we're just going to grab the right one. We're going to just label these I and k. And then what's our maximum k? Oop, I did that wrong. Ki. Alright, let me redo this. Alright, it's going to be 12 minus 8 times times 7. Alright, what's that going to be? That's going to be 4 times 7, 28. 28 is not bigger than 48, so we're just going to continue and ignore this one. Oh. I don't want to do that. Alright, now we're at index 3. Alright, our nums I is going to be 12. Our nums j is going to be 2. We're going to multiply by our nums k, 7. Just following this general pattern right here. And we're going to see this is actually 10 times 7 is 70. 70 is greater than 48. So our new greatest value is 70. And then we're just going to keep continuing along the array. So in this example, this would be 12 minus 5 or 7, which is 5 times 5, 25. That's not greater than 70. And then this one here, it's going to be 7 times 4, I believe, which is 28. Not good enough. So 70 is our answer. Boom. That's how you solve it. And then just one note. It does clarify if all such triplets have a negative value, return 0. So we're just going to return the maximum of ands 0 max. So that is how to solve this problem. And if we analyze the time complexity, remember when in our naive solution where we set j and we like iterated left and right, this was actually a O of n squared solution. But since we did these pre-computations, each of these pre-computations cost O of n. And iterating through this array is O of n when we want to experiment with our j's. So this is actually going to be time of O of n, and there's a space complexity of O of n. And here's just a simple little bit of code to explain it. So we have our max right of index, our max left of index, and then after we compute those, we set our ands, we get our triplet value as we did in the example, and then we set the maximum of our answer and triplet value and return essentially 0 if ands is negative or ands. And I do want to point out this, while this is a good solution, there is a solution which is slightly better, which is time of O of n and space of O of 1. Now I want to challenge you guys to see if you can solve this. It involves getting like a running count and storing the max diff and stuff like that, but it is possible. But you want to iterate along starting at the first index. You don't need to worry about any pre-computation. You're going to be storing the max diff and some minimums and maximums, but I won't get past that. But there is a space of O of 1 solution. But yeah, that was, what was this? Leetcode 2873, and I hope everybody learned something.